Hi everyone, very good evening. I welcome you all for today's webinar, AutoCAD Mechanical. Okay. This session is for AutoCAD users who are using the plain AutoCAD for more than a decades and who want to switch over to AutoCAD Mechanical or who want to improve the productivity in the plain AutoCAD. So for them, this session will be very useful. Okay, right. So what is AutoCAD Mechanical? And AutoCAD for more than a decade, it's a plain AutoCAD, right? Where everyone will be using as a common tool. Where architects will be using the AutoCAD, manufacturers will be using the AutoCAD, as well as electrical peoples will be using the AutoCAD. Okay, so it has its own advantages as well as it has its own disadvantages. So advantage like it's a common tool which can be used by everyone. But the disadvantage is like we could not able to extract the information that is specifically for the particular industry. Let's say manufacturer people want particular information from the AutoCAD, and electrical people want that electrical information from the AutoCAD, and the architect people want architecture information from the AutoCAD. So for each and everyone, they need to customize these AutoCAD based on their own industry, and they need to work with the plain AutoCAD. Okay, so that puts the another option with the Autodesk. They came with special tool sets for each and every industry. Okay, and you have special tool set for manufacturers, and you'll have special tool set for electrical peoples, and you'll have special tool sets for each and every industries. Okay, so if you are working with AutoCAD for many years and you know how it's difficult to extract the mechanical information from the plain AutoCAD. Okay? For example, if you want to take the bill of materials, and you know how it's difficult, where we need to generate a table and then we need to put a data and we need to extract those data from the AutoCAD, and finally we need to generate that one as a bill of materials. So all these things will be simplified within a few clicks inside your AutoCAD Mechanical. The same goes to AutoCAD Electrical also, where we can easily get the wiring data and what are the components that is present inside the electrical. So all those things that can be easily extracted with the AutoCAD Electrical. Okay, the same thing goes for AutoCAD architecture also. So with specific tool sets, it's a more advantage where we can reduce more time than compared to the normal AutoCAD. Okay, so that's the main advantages of AutoCAD Mechanical, and that's why today we're going for this topic, how we can reduce the time, how we can improve our productivity when we switching over from AutoCAD to AutoCAD Mechanical. So, and what are the advantages? So that's the main agenda of today's topic. And if you're wondering how you get the AutoCAD Mechanical, and if you are a, PDMC client, product design manufacturing collections, if you have that, and so the host of tools that is present inside the PDMC collection. So all these are 3D tools, Inventor, professional cam and tolerance analysis. I hope if you are gone through our previous session, maybe we have covered all this. At least we have covered at least one topic from each and every tool here. And this AutoCAD Mechanical comes along with this AutoCAD toolsets. Okay, so what are this AutoCAD toolset? Again, this AutoCAD toolsets will consist of bunch of these softwares. Okay, and this is the main plain AutoCAD that we are using for more than many years. And what Autodesk did is like they brought some specific toolsets for each and every industry. Okay, and this architecture toolset is for architectural peoples where they can extract their architectural information easily from these one, and you'll have electrical toolsets. And this is our mechanical toolsets, and this is what we're going to see today right now. And also for the piping and process plant industries, they have came up with some special toolsets for Plant 3D and P&ID toolsets. And this is for the facility management peoples, and they can do their MEP designs using the MEP toolsets. And this is for the civil people, they can do the Map 3D using the Map 3D toolsets. And we will be also having the raster design toolsets where we can scan the drawing. Let's say if you have any old drawing, we can scan the drawing and we can edit that image, and we can also convert that one to a AutoCAD. So that's what we can do with this raster design toolsets. And apart from that, you will be having this cloud applications. This is what you will get from this AutoCAD toolsets. And if you're on the industry where everyone is working, you are electrical as well as if you're a project industry, if you're having the requirement of architecture, you can make use of it. Okay, and today we're going to discuss mainly this mechanical toolsets. Here you can see that topics are different, but everything will become like AutoCAD architecture, AutoCAD electrical, AutoCAD mechanical, and then AutoCAD Plan 3D and P&ID. Okay, uh, right. So let's get into the main topic. Okay, so what is the difference between AutoCAD as well as AutoCAD Mechanical? Okay, uh, so just let us move some history how we got AutoCAD Mechanical into the Autodesk. Okay, so whatever we can do with AutoCAD, we can also able to do with this AutoCAD Mechanical. Okay, so initially, people who are from the Genius technology, they have developed the some kind of mechanical application to the Autodesk, and so they had an initial release at the like mechanical desktop 2.0 with that add-in to AutoCAD 2014. Okay, so later that add-in will be converted into a full feature which is having dimensioning tools, mechanical symbols, bombs, and everything. And finally, Autodesk has acquired that's Genius technologies into the Autodesk, and finally this AutoCAD Mechanical came into the Autodesk family. Okay, so that's what the history of this AutoCAD Mechanical, how it enters into the Autodesk, and after that all the tools they have made for each and every industries. Okay, and if you plainly see the difference between AutoCAD Mechanical as well as AutoCAD, we can't find much difference. Okay, so let me take to the software, and we can see here. Okay, uh, so if you're an AutoCAD user and this is a plain AutoCAD. Okay, so this is a main plain AutoCAD. Okay, let me go to AutoCAD Mechanical, where the while saying itself you can find the difference. And the first main difference you can find is like if you go to this option menu where you can where it will be like AM, that is mean AutoCAD Mechanical, where in plain AutoCAD you can see it's been provided with only the A. So that's the main thing you can identify while you opening AutoCAD Mechanical. And the other thing that what I said, you can also do the AutoCAD function inside your AutoCAD Mechanical also. Okay, so if you when I go to this workspace here, you can see along with the other things, you can also go for mechanical, and you will also go for structural and the 3D basics and 3D modeling. So these are the functions that's already available in the plain AutoCAD. Okay, and when we go for the other difference like the commands and toolbars, more or less same, but something has been added to unique to the AutoCAD Mechanical, where we can see home tab, insert, parametric view. These are common to AutoCAD. And when I move to AutoCAD Mechanical, uh, so everything will be the same. Okay, if you go to the home tab, but here you can see this content tab. Okay, they have added one more tab here, this content, and it's again unique to the mechanical manufacturers. Okay, so where it contains all the standard uh, library content which is specifically used for the manufacturers, right? And next thing, if you go to this home tab, it may look similar to AutoCAD, but there are some quite some features which is unique to this one. And if you just go to this line where we can see we'll have different types of lines, right? And if you go to rectangle, and you can see the difference. And whereas if you go to the rectangle in the plain AutoCAD, this is what we get. And when you move to AutoCAD Mechanical, and you can see there are something different types of rectangle that is available inside the AutoCAD Mechanical. So again, using these things, we can easily create our own rectangle, which is specifically for the manufacturers. Okay, and what else we have? You can see there are something which is unique to the construction. That is, we will call as a X line in normal AutoCAD. There are many things they have given with the construction line. So if you want to draw something using these reference lines, it's easy for you to easily draw using this construction line. And they have come up with some other features like height situation. So we'll just see how it will work. And the important thing here is like uh, this thing. Okay, so where we will have power dimension, which is again unique to the AutoCAD Mechanical, and you can see the host of symbols, which is mainly useful for the manufacturers, the welding symbols and the grinding symbols and the host of other symbols, which is very very unique to the manufacturers. So these kind of things we can make use of it, and we can improve the productivity. And the other tools is like we can also have the bill of materials, and we can also see part reference. So this makes it quite different than that of your AutoCAD, where we don't have any specific tools for to generate the bill of materials from the set of drawings that whatever we have. But they have created a nice thing for to generate a bill of materials. So where within few clicks we could able to generate BOM from the AutoCAD drawings. Okay, and also we will be having title borders and pot list. We can take the pot list, whatever assembly that we're going to draw inside our AutoCAD Mechanical, we can also able to take pot list from that one. And the nice thing, we can also able to take whole chart as well as the fit list, whatever drawings that we're going to make. Okay, so we saw this content center, and one more thing is like structure. Okay, so this makes again unique with respect to AutoCAD Mechanical, where we can create a organized drawing inside your AutoCAD. Okay, where we can generate different component views, and we can segregate different components based on the names. And if you want to if you want to filter those contents, we could able to easily organize those drawings. So if you're going for any larger assembly, this structure tab will be very very useful for you. Okay, so these are the some of the things which makes quite unique to the AutoCAD Mechanical than compared to AutoCAD. And what I like from this one again is like this one. Okay. We can also bring the model directly from the Inventor. So maybe if you saw our previous session using the Inventor where we are doing some modeling, so we can also bring the 3D modeling components into the AutoCAD Mechanical, so that it will be having a link between from your Inventor to as well as to your AutoCAD Mechanical. Okay, so if you are a guy who are trying to switch over from your 2D to 3D tool, and you can make use of it. So even by using this 3D tool, you can directly bring those models into your AutoCAD Mechanical, and you can do the detailing here itself. Okay, and we will be having nice add-ins along with the AutoCAD Mechanical, and this is my factory layout, and so you can do the factory layout designs using this one also. So it's a 2D layout actually. Uh, so there are quite add-ins. So these some of the add-ins, which is again very very unique to the AutoCAD and Mechanical. So where it will always communicate with other tools also, right? Okay. So just a quick overview. So there is some productivity study done by Autodesk, which they compared with the normal Autodesk users. Okay, so from the study they came out with some results where we could able to increase our speed as well as the accuracy when we moving from AutoCAD to AutoCAD Mechanical. Okay, so when we going with drafting and annotation, maybe which takes 100% of time in which it takes 1 hour in the normal AutoCAD, where we can able to reduce within 30 minutes. Okay, within where we can able to reduce 55% of time with the plain AutoCAD, sorry, with the AutoCAD Mechanical. Okay, and the design task where we could able to do much faster, 85% than that of plain AutoCAD. Okay, so we can also able to reduce our errors, and we could able to finally we could able to save the time when we moving from AutoCAD to AutoCAD Mechanical. So there are some productivity tools and that we're going to see right now, and this is based on the study where how for the manufacturers how it will be help to reduce overall task and the time here. And so there are various stages uh, of implementation of this AutoCAD Mechanical. And if you come to the standards, and this is your annotation, and based on the design and engineering task, where we will be having many components which will reduce your many headache task. Let's say if you want to build any parts which is specific to your design. Let's say you want to build the bolts. What we will do with plain AutoCAD? We will be converting that one as a block, then again we need to give some information to that block, and then we need to insert that block into our uh, AutoCAD drawing, right? So here that is not the case, where we will be having all our standard content inside your AutoCAD Mechanical, where we can directly take and drag and place it inside. That's it. Even your bomb catches those information, and finally will get you could able to extract those information very easily. And not only with that, we will be also having some advanced features which is helpful for the manufacturers, where we can also do the FEA, and where we can also do the moment of inertia, and where we can also go for the cam and bearings and those things. Okay, and right now we're going to see overview of all these things, and we're not going to limit with some specific tools, and we're going to, in this introduction, we're going to see overview of everything. Okay, so first we can start with the standard management. Okay. Right. So as I told you, the difference between the normal AutoCAD as well as plain AutoCAD, and where we can see the much, where we can't see much difference with the plain AutoCAD. Whereas when we moving from AutoCAD to AutoCAD Mechanical, and we can see the quite, there are so much difference, right? Okay. So first, I want to show you some standards. So mostly as a guys of using mainly when we are using the plain AutoCAD, we used to struggle with the standards that we're going to choose. If you are using the ISO standards, where we need to go for some sort of text textures for that one, and spacings, and the different set of tools, which will be again vary based on the standards. So each and every time we need to set that one in the plain AutoCAD, right? But in AutoCAD Mechanical, that is not the case. They have given the settings which is unique to each and every standard. Okay, so let me go to this. Let me right click here, and let me go to this option, where this is this common to your normal AutoCAD, but what makes this option different is like here, where we can see AM. Okay, this AM stands for AutoCAD Mechanical, AutoCAD Mechanical Structure, AutoCAD Mechanical Drawing, and AutoCAD Mechanical Contents and shafts and calculation, these kind of things. Okay, so I'm going with AutoCAD Mechanical Standards, and you can see they are given all the standards, global standards. Okay, ANSI, BSI, ISO, and Japanese standards, and all these things. Now, if you're working with the guy of let's say if you're working with ISO, that's it. Within a click, all your dimensions has been, all your settings has been set already. Okay, your dimensions with respect to the ISO standards, and your whole chart and your drawing sheet. So everything has been already predefined based on the global standards that is already available, so that we don't need to set each and every time all the standards. That will consume more time. So here we can able to reduce much more time than compared to that of our plain AutoCAD. Okay, so this is a main standard management that is available inside your AutoCAD Mechanical. And if you go further inside, if you want to change any of the settings, where we can do that. Let's say if you want to change the settings of, let's say, dimension, where we can go to the settings, and where we can change how we need here. Okay, and let me open a drawing, and let me show you what are the other difference here. Okay. And if you see this drawing, okay, so it is having some set of features which is present in AutoCAD Mechanical. When I switch over to my layers, you can see there are some layers which starts with AM, right? AutoCAD Mechanical, and some other layers which is going with like plain AutoCAD. Okay, so the other advantages with the AutoCAD Mechanical is it has its own set of layer management. Okay, so let's say if you want to draw the same drawing with the plain AutoCAD, what we have to do, we need to generate the layers for this one, and for this hatching pattern, and for this section views, and for each and everything we need to set up layers inside your AutoCAD. Okay, but in AutoCAD Mechanical, that is not the case here. Okay, so let me give you one quick example. Let me take this center line here. Okay, let me go for a new drawing. Let me take one center line here. Okay. And you can see when I draw the center line, automatically it is taking a layer which is unique to the center line. It is based on the standard ANSI that we have selected. And when you just select this, you can see you're getting this one as a AM7. So this AM7 is unique to the AutoCAD Mechanical, which directly takes this layer management, where we don't need to define anything. Directly, it will give you the some set of already defined layer setups. Let me take these one. Let me take this construction line, for example. And you can see this one. Let me click this, and you can see it directly give a new layer, that is AMCL. Again, we don't need to set anything here. So directly it takes the standards, and it manage on its own. Okay, and there are quite other layers also. So if you want to take this layer management, where you can find is like you can go to this options, and if you go to this standard settings, where we will find our, okay, here you will find this AutoCAD Mechanical Manage Objects, Object Properties. So here they are given a unique layers for each and every object features. Say for part list, and what is the color, and what is the layers, and for the section view, what is the layer AM10 and plain line AM10, and for the text and what it has to follow. So these things are customizable on our own, and but if you going with initially, this is the standards already Autodesk is providing based on the global standards, maybe ANSI or ISO. Okay. And you can see when you go to the drafting, and for each and every features for auxiliary line, you have AM4, and for contour, and for hatching patterns, and everything has been set already. So only thing we need to do is like we need to take the geometry and we need to draw. That's it. Okay. So where our main, it be this layer management may take much time in the plain AutoCAD, right? So those times we could able to save inside our AutoCAD and Mechanical. Okay, so that's how it's efficient is. Right. Here in this drawing, if you take where already the predefined set of them, this is the layers which starts with AM is AutoCAD Mechanical. It already took from the standards, and the other standards like how we create in the plain AutoCAD also we could able to create on our own. So it's having that flexibility also. Okay, so not only we need to go with only these mechanical layers that provided with AutoCAD Mechanical, we can also create our own layers inside this layer management, and we can also do those things. Okay, so it's more flexible compared to AutoCAD. So let us go with some of the tools, and so first one, as I shown you, the rectangle. Okay, how it different from that of your plain AutoCAD, where they given so many different options. Let's say, let me start with line then. Actually, so if you go to this line, you can see this is a plain line. That is what you do with plain AutoCAD. There is not much difference, but when you just go to this symmetric line, it makes a difference. Okay, so I think it won't be available in the plain AutoCAD. So let me take the symmetric line and let me show you what are the difference. So first it will ask you to line this center line. Let's say that's my center line here, and next it asks you to draw something at the end of this, other end of the center line. So let me draw something like this. And you can see when I draw here, and automatically there are other projections which is drawing on the other side, okay, like a mirror. So you can see now how easy the task is. Let's say if you're going to draw any section view and we want to uh, draw the first off, and automatically the next off will be drawn automatically. Okay, so that you don't need to where half of your work is gotten reduced, right? So in that way, it is very efficient, and this is again unique to the AutoCAD Mechanical. And if you want to draw any zigzag lines, where you want to show any, you can see, if you want to show these zigzag lines also, you could able to draw using your AutoCAD Mechanical. Okay, just I'm showing the different tools which is unique to the AutoCAD Mechanical, and these tools again the same. Whatever we see with AutoCAD, these are the same thing, and these are commands. And the main thing which is again unique to this AutoCAD Mechanical, these commands, the centerline commands. Okay, so where we will be having center line for different settings, and let me show you. Okay, so it's an automatic center line. So when I just normally draw any center line, that's what you will get, and automatically mechanical will assume take the layers for this AutoCAD for the center line. Let's say if you want to draw the center line cross, so sorry just select the center point of that circle, so automatically you'll get this center cross like this. Okay, and if you want to adjust these settings on settings of the center line, we can go to this options. Sorry, we can go to this option, and if you go to this center line here, and if you come to the standard where you will find the center line, so where you can go to the settings, and here you can fix your overshoot length and other settings that is again unique to the center line. So those kind of settings also we could able to customize. Okay, and let me take this example. Okay, center line cross on plate. So what it does is, like, let me draw one rectangle. Here there are different types of rectangle. Okay, so first one is like, this is a normal one what we do with plain AutoCAD, and next if you go here, like let's say is like full base and full height. Let us draw this one. So first it is asking me for first corner. Let's say that's my corner point, and next it is asking me the base length. Okay, so directly we can give our base length. Let's say 100, and next I'm going for 100. So I'm going for 100, and let me enter. And another one, let me enter this 100. Okay, so this is nothing but my 100 by 100, 100 by 100 plate, right? So now let me take this one example, the center line cross on plate. So what it does is, like, so first it is asking me to specify offset on my center cross. So from here, what is my offset? Okay, so this one directly place the holes on your plate. Okay, so let me give this one, let's say 5 here. That's my object, and let me right click here, and next it is asking me to insert. So where I want to insert, whether outside of my rectangle or inside my rectangle. I'm just selecting the inside. Next it is asking me to select diameter of hole. Okay, even AutoCAD Mechanical has given you a nice feature. You can also bring the standard parts into your uh, plates, or else you can directly mention your diameter. I'm going for diameter, so let's say 10 here, and you can see with the 5 mm it has created a offset. Okay, so let me measure that. So there's a 5 mm offset from my plate. Okay. So once we given that offset, automatically we will get the holes in all the four sides. But in case, let's say if you want a unique one, where we can able to control the different offsets. So and that in that case, you will be going for the centerline crossing corners. Okay, let us quickly go into this one. So first, it is asking me to select first contour line. That's my first contour line, and that is my second contour line. Okay. So next, it is asking me for offset. So in this case, let me give 20. And next case, second contour, let me give 30. Okay. So diameter, let us go for same 10. And you can see it's created with 20 and the 30. Okay. Uh, so that's my 30 here, and that's my 20 here. So there are many tools here, and let me go for it. And you can see, so when I just select the first one as well as second control line, automatically it will create a center line between the two counter lines. Okay, so that's another way. And so I want to tell you this one. Okay. Let's say if you have multiple holes. Okay, so if you have n number of holes, you have n number of holes like this, and within a few clicks you want to generate all the center lines to this one. You can go to center line cross in holes, and directly you can select the objects and right click. Automatically it will place this center line. You can see here the offshoot, and here for this offshoot everything will be the same. Okay, and it will directly recognize the diameter of your circle, and it will generate the offshoot length standards. Okay, so and there are quite different center lines available here, and we can try those things. Okay, and you can see also if you're going for any hatch pattern, and I want to tell you this. So if you're going for any hatch pattern, let me click here, and you can see this hatch patterns again. And just select. You can see this one again. It has make it AM8. So this layer we not even generated any new layers for that. And automatically AutoCAD Mechanical recognize this hatch feature, and it will generate its own layer management. Okay. And you can see there are different types of construction lines that is available inside your AutoCAD Mechanical. Let's say that's my line construction lines. Let's say if you want any automatic construction line, or if you click this one, and you can see here a host of different construction lines that is available. Just let us go with few things. Let us do this one. Let me select the circle. You can see there is no my construction line. Again we have a separate construction line for our circle. So this is what actually we are doing. Let me draw one circle here, and let us go to this one concentric circle. Let me select the circle, and it is asking me to select the center point. Let me give the diameter, let's say 500. And you can see it automatically created a concentric circle for me. Okay. There are so many ways of you can handle this construction line. There are many options here. Okay. So Let us take, if you want any, uh, we'll just go with this one. Let me take this example and let me select this circle here. And you can see automatically it will give you a circumscribe rectangle to your circle. Okay, and so we can try this one. There are quite many features with the construction line. Okay, see, I have drawn so many construction lines here. Okay, so again, you don't need to delete each and every construction lines here. So what we can do is like we can directly go to this construction within a few clicks. So here, within a few clicks, what happens? Automatically, your construction lines will get erased. Okay, so that's how powerful your AutoCAD Mechanical is. And next, let me come here, height situation. So what it basically does is like, let's say you have two plates. Let me go with some example. This is my plate one, and let me draw one more plate. Okay, and that's my another plate. See, this plate is top of my first plate. Okay, so how we will show in our plain AutoCAD, where we need to trim this one, or we need to, so again we need to draw some hidden lines which is no, to show this to our manufacturing drawings. Okay, but here that is not the case. You can directly go to this height situation. We can create something like this. So it is asking me to select foreground object. That's my foreground object. Let me right click. So what happens? Directly you can see, directly it will generate the hidden line here. Let me select this line, and you can see there is something, it has been created, AM3. Okay, that layer is nothing but a hidden line. See how quite easy it is to generate a hidden lines between your two components. Okay, this in this case I'm just using rectangle, but if you're going for any different objects where we need to create as a block, okay, so then it could able to easily recognize the inside lines that is going in between the components, and it will make that one as a hidden line. Okay. Okay. Here we could also able to give the building actually. So let us go with some example. Let's say if you want to give any building representation, what we need to first do is like we need to use some line to this one, and where we need to give that building. Let's say let me take that center line. Let's say if you want to go, you want to show this one as either fillet weld or groove weld or whatever it may be, you can go to this detail and where you can select this weld representation. Okay. So you can select the type of weld you represent here, and just I'm going for the simple one, single V butt weld. Okay, let me click OK, and it is asking me to select leg width, and let me give something like 30, and that's my line here. So when I just click, see what happens, automatically it will generate a welding lines for you. Okay, and one more case, and let us go for another type of weld. Okay, let's go for fillet weld here. So I'm going for this fillet weld here. Okay, so let me click OK, and leg width, let me go for the same 30, and let me insert here. So you can see, so automatically it inserted some building symbols here. So this is how quite powerful it is. So if you want to go for any detail view, or if you want to go for section line, okay, so it won't generate automatic section view for you, but it can able to give some section lines, based on the views that you have placed already. Uh, so this detail view. Let me take this example. So if you want to give any detail view to this one, okay, so go to this detail. Let's say you want to show some detail view here. Just select that, and it will ask you to select the view scale of your detail views. So you can take that, and you can, let's say you can provide. Okay, so it isn't 2:1 scale, and that's why detail. Okay, so you can do like this also. And other thing that what I like from AutoCAD Mechanical is no, there are something which is difficult, different here. And when I just hover my mouse, you can see this move. That is again in, the same thing with AutoCAD. Okay. But when I take this one to my offset, you can see there is something we're getting with AM offset. Right, in the command world is showing AM offset. This AM is nothing but AutoCAD Mechanical again. So whatever commands that starts with AM, that is unique to the AutoCAD Mechanical. Okay, and uh, this one you can see AM breakpoint, and this is the same. So whatever commands that starts with AutoCAD Mechanical, that is unique to the AutoCAD AM, that's unique to the AutoCAD Mechanical. Right. So here, let's say if you want to draw, this is my circle. Okay, and if you want to go for multiple offset, let me give this specific distance. In plain AutoCAD we can go for the offset only in the we can go for only the common offset. But if you want to go for unique offset, take this circle as an example, where you want to go, where you want to give the offset as a 10, and also you want to give the offset as a 15. So within a few clicks, we can go for different offset for the same object. Okay, but in the plain AutoCAD, that is not the case, where we can go for only the equal offsets. Okay, so here I'm just clicking this offset. It's a AM offset. Okay, and I'm taking the offset distance. So it is asking me, let's say 20, and this is the command you will have. Okay, you can press the shift and that bar, and I can go for 30, and I can go for multiple offsets. So I can go for 40, I can go for even, let's say 100. Okay. So 1, 2, 3, and 4. So let me enter, let me select the object, and it is asking me inside or outside. You can go for inside or you can go for outside. See how it generated 20, 30, and 40, and that's my 100 offset, where we can go for different types of offset for the same object. Okay, and if we come to this layer, where we can see no different layer switching of options, and this is for your standard parts, and this is for your construction lines, and so for all these things they have given unique settings for the layer management. Okay, so without wasting time, let us go for other options also. It's just an overview of how AutoCAD will work and what are the different commands that is available inside your AutoCAD Mechanical. And the other feature also, you will have something called power copy, so which copies the identical information from the AutoCAD Mechanical. Okay, so this is the copy we use. We are using the plain AutoCAD, but power copy is different from that of your normal copy command. So it takes all the information and it will create the object along with that information. Okay, and also we will have some power commands. We will also have power dimensions. So it will easily recognize the objects. Okay, let me right click and enter, and it is, let's say, I just click this one, automatically it will recognize the, see, when I just select the circle, it directly starts with this 5302, that is the dia. Okay, where we don't need to say anything, so directly it will give you the dimension here. Okay, and let us take with another example. You can see it directly took the my width of this. Okay, so let's say if you want to give sorry, let's say if you want to give any tolerance or anything to this one, you can go to this tolerance, and where we can give the different tolerance. Okay, so whether you can, here you can represent your upper as well as lower tolerance. So this one gives you different types of tolerance setup, whether you want to go for deviation or you want to go for symmetric. So here you can select the type of tolerance, or directly you can see you will get plus or minus zero point 0.1 here. Okay. Also you can go for fits as well, and let me give the fits here. So you can see it will take you to the fit dialog box, where we can generate you the what type of fits for your holes as well as for your shaft. Okay, And if you want to give the tolerance, we can also get the type of tolerance we need, and we can give these things, right? So, so everything will be quite available inside your AutoCAD Mechanical. Okay. So let me close this one, and we'll quickly move over to other comments. So this is what you will have in this home button, and let us just quickly go to this bomb. Okay, so this is what actually I want to show you. Let me take this example. Uh, so I want you to know, see how easy to generate a pot here. Okay, already we have a setup drawing, and it is where we will be already having this thing, this pot list, and you can see to 7, and I'm having one more thing, that is the dry shaft here. Okay, so let me take some ballooning here. So let me go to balloon, and let me select the spot. Okay, when I just select this spot, and let me go to accept, and you can see directly recognize the pot number 8. That is nothing but my dry shaft. Okay, so how it will work, and let me show you some example. So let's say, let me take one rectangle like this. Okay, and let us input some standard content into this one. Okay, I'm just going for simple screw connection here. Let's go with some hexagonal bolt. And that's my insertion point, and that's my length of my bolt. And I'm going for M36, and you can see that's my bolt information here. Okay, so click OK. Now, when I just take, you can see there is something which is inserted along with that one. So this is called as a pot reference. Okay, but we don't have any pot reference to this one, this plate. So consider this one as a rectangular plate, and this rectangular plate we have inserted some screw connection inside to this one, right? So when I insert my screw connection, automatically what happens is like it includes this pot reference along with that. So it will directly comes into your bill of material. Here we not yet included this bill of material. Consider that one as a plate. So what we do with plain AutoCAD, if you want to show this one as a plate, and you want to show this one as a screw, so where we need again we need to take a table, and we need to extract those information, and we need to finally generate a bomb. So it may take another 5 to 10 steps. Here within a single click we could able to take this one. So here you can see in the bomb tab where we can see something called create option. Okay. Pot reference. Just clicking something, so it's asking me the name. I'm just giving that one as a steel plate. In description we can give anything, and we can give, let me give like, let's say machine, and this is what's the standard, give C, and measurement. So these kind of things we can enter, and what are the unit, just in or whatever it may be, right? So if you want to go for other settings also, we can go and we can enter, and let me click OK. And if you want to add other rows also, we can go to settings and we can add here. So for this I'm just entering the information of this part, and let me click OK, right? So this is one of my part, and for this already when I took the component from my library, it already gave that information to this one. Okay, and now let us take the pot list, where along with this 8 components, okay, sorry, let me show you. Okay, so along with this 8 components, you can see directly it updated 2 more components here. That's my ninth component, and that's my 10th. So whatever we have created. Okay, now let us take the ballooning information to these one. So let me go to the same home tab, sorry, same annotate tab, and let me go to balloon and let me select this one, where you can see that's my component number 9, and let me take this one, and you can see, and that's my component number 10. Okay, see how easy it is, and directly within a few clicks we could able to take a BOM information and directly it updates here. Okay, so this one 9, it takes the information from your standard content, and from the 10, but whatever information that we are given, it directly takes that information, give you the balloons and everything. Okay, so for the BOM setup, you can go to this bill of materials here, and you can see all the information. Okay, so if you want to export that one to Excel sheet or to a XML format, we can also generate that one. And in any case, if you want to customize your BOM, you can go to this options, where you can select your standard, and you can go to this BOM, and there you can go to the settings, and here you can enter the different values here. Okay, so maybe based on the rows or based on the columns, here you can enter here. Okay, so you can also customize your BOM settings by going to your options. So here we also saw how to place this content center. So let us just quickly over to this content center. So let me go to this content library here, where it has all the standard libraries that is available inside your mechanical features, holes, tapped holes, and my fasteners and everything. Okay, so we can see if you take any screw template, it contains as a set, okay, where we can also give bolt connection along with washer, with the hole and the end washer, and it sends with your nuts. We can directly customize these information, and while we insert this one into your AutoCAD Mechanical, where everything will be available as a set. Okay, so like this we can set as a screw templates we can set, and directly we can insert, where much of our most time has been reduced while we setting this screw assembly template, where everything will be setting within a few clicks. Okay, but in case if you want to insert as a separate component, let's say you want to insert only this screw or only this nut or pins or whatever it may be, you can also insert that. Okay, uh, so this content is for this the library that is available inside based on the different standards. And in this content manager, you can manage this content. You can customize those things. You can see when I go for this anything, we can see different views of that holes here. Okay, let us quickly just create some of this content and let us see how it will work. Okay, I'm going with the same plate connection here. Let us create some holes here. So let me go for some holes. We go to this content and let us go to this through holes. Okay, you can also bring your all this content through this content library, or you can go to the specific feature. You can also bring from here also. Okay, so in either way it will work the same. So I'm going for through hole here. So you can select the type of hole. Okay, so I'm going for close metric or normal metric, or so it may be. Let me go for front and let me select these center. Let me the length of the hole. Okay, then it will ask you to select the standard. Let me select the size and let me give the finish. Here the case is M36. So when I just select, you can see automatically that it has created some pot reference form, right? And next, let us insert some screws here, and let me go to screw, and let us select some hexagonal type screw. See, when I just select, it is giving another 4 option, whether you want front view or top view or whatever, what view you need. So here I'm just going for the front view. Let me select the insertion point somewhere around here, and let me go for same M36, and you can see just created the bolt along with my hole here. Okay, so if you don't want to insert hole, then your bolts and then your washers and then your nuts, you want to go as a single setup, you can do the screw templates. Okay, where we can able to reduce much time. So while we placing automatically, you can see there is spot reference. It is automatically referring this component to your BOM management. Okay. Uh, that is for your standard contents. You can easily take from your library where we can see more than 1,000 components, where we can bring everything within a few clicks. Where this thing, if you want to do with the plain AutoCAD, you can imagine how much time it will take. Okay. Within a few clicks we can do with this AutoCAD Mechanical, where we're saving much time here. And one more nice feature I like with the AutoCAD Mechanical is this representation and power view. Okay, so what it will do, let me just check here. Okay, one more thing, if you just select this one, and you can also change the size here. If you want to go for other diameter, let's say M30 or M24, you can also later, we can change our mind, we can change that things also. And this power view, so this is, I quite like this feature. And let me take this power view, let me select the object. Okay, so let us see what it does. Directly select, directly recognize that bolt, and it gives you different views. And if you want to generate the different views of this one, let's say I want top view of this one. Okay, so where I want, this is where I want this top view, and you can see directly generates the top view for me. Okay, see how quite powerful it is. So where we don't need to do anything, so within a few clicks we could able to generate a different views for this one, right? And if you want to change the representation, so you don't want this much of detail, let me go for change representation. Select the object, and instead of standard, I want to go for simplified view like this. And you can see it has changed the simple view like this. Okay, so like that also we could able to change our representation here. And finally, let me go to the shaft generator and let us see how it will work. If you go to the shaft generator, and first it will ask you to set the center line here. Let me use some lines. So once you take the center line, and it will ask you to three options. Okay, one is the left, outer, and the right. Okay, so first we need to draw the outer contour, and let me take this example. So here, let me give something like this. Okay, let's say 350 or 340 like this. And when I just click, and it will ask me the other options where we can either expand or contract, or we can give the different diameters to your shaft. And let me finally hint somewhere around like this. Okay, let's say once I given this one, so let me go for, again we'll just do that, and let me give the outer contour, and let me go for other one. Let us let me give this one, let me in somewhere around it. Yes, so once you given that, and you can see it is asking other options where we can enter left inner contour and right inner contour. So these options are meant for if you want to insert any O's at the left hand side, or you want to insert any spines, or anything, the unique feature you want to insert at the left hand side, or you want to insert at the right hand side. Here you can see host of features that is available in the AutoCAD Mechanical. Or if you want to insert, let's say, any keys or keyways inside to your shaft, you can directly go to the standard parts, and you can directly insert into your AutoCAD Mechanical. Okay, here let me insert some holes or cylinder feature inside on my left hand side, and let me click that. You can see, so I can click like that, and I can go to this right side, and I can take another small hole here. Okay. And once it is over, let me click OK, and you can see, maybe you're not clicked here, I think so. So you can see, in the left hand side, directly that's generated the hidden lines for your shaft like this. Okay, so in that way we can go for shaft generator, and there are other options also, and for bearings and for all the mechanical components, you can use this one, and you can try these things. Okay, and we will try to cover in the upcoming session, so which is unique to this calculation and this shafts. And finally, I want to go with this steel shapes. We select the steel shapes, and here they have given many structural shapes like this. Okay, I and many shapes, and let me select this I shape here. Let me go for this front view, Let me insert, let's say somewhere around here, somewhere around here. So then we need to select the type of a section, my size, and I'm going for, let's say, this one, and we go for next, and we need to select the length. Okay, let me just give finish. So here we're not able to see the length, but that length will be used for the no, calculation purpose. Okay. So once we did that, and that's my I section here. And if you want to go for any moment of inertia and deflection line for this structural shapes, you can go to this calculation tab where you will have something called moment of inertia. We can generate the interior points here, and so once you generate, it will ask you to where you want the load. You want to give that load. So I'm just giving in this direction, and let me give that one as a okay, and it's asking me for the insertion point. Let me enter somewhere around here. It's very this, I think so. That's my so that's my moment of inertia table. So which calculates based on the load that we have given here. Okay, and if you want to go for any deflection lines, again you can go to this deflection line, and let me draw one line before that, and let me draw a line here. Yes. And for that, if you want to go for any deflection line, you can go for this content. Let us go for this deflection line, and let me select the moment of inertia block, and that's my starting point of the line, and that's my ending point of the line. So once we select, that will take to this dialog where we can generate this beam support. So let me give somewhere around here, and let us go for another support, and let me give that support, say somewhere around here. And for the loads, I'm going for the uniform load, and let me use somewhere around from here to, let's say here. I can see directly generates the load, and the load I'm going for, let's say 100 newtons per mm. And if you want to give any point load in between also, you can generate this point load here. Okay, let's say if you want this point load somewhere around here, you generate that one, and also you can give the load there. And if you want to select this materials, you can also material from this material table, and you can select that. So once you have selected your material, so you can also edit your Young's modulus and these values. And finally, you can tell the software what you need, whether you want moment and deflection or you want only this deflection. So here I'm going for moment and deflection. Let me select that. Just going for the title name. Let me click OK. Click OK, and you can see that's my line, and that's my deflection line here. And it also gives you some table information, and you can see, and let me just scale it. And that's my final thing what I get from a bending moment diagram. Okay, so what is the max bending moment and deflection, and so these kind of things you will get for your structural shapes here. Okay, and finally I want to show you this FEA. There are a host of other features which is available inside, where you can go for spring calculation. Also, we can go for the sprockets and your chain build calculations. So these kind of calculators also available inside your AutoCAD Mechanical. And finally, I want to end with this FEA section. Okay, let us take something like this. Okay, I'm just taking one plate. Let's say let me take this one as a cantilever beam, and let us go to this content, and let me go to this FEA, and that's my insertion point. And it is asking me for supports. Okay, first let me give the support, and that's my support here. Say from here to up to here. And I can see directly generated my support case here. Okay, let me zoom it, and next I need to apply the load. Okay, see that's my support, and for my load, let's say this is where I want to apply. and let me give, let's say, 2000. Okay, yes. So that's it. So once you generate, you can go for this mesh settings. Also, if you want to give the thickness of the plate, you can give, let's say, I want, let's say, 10 mm, and you want to go for any materials, you can apply the materials here. And finally, if you want to give any mesh settings, and that's my mesh settings. Okay, and if you want to control, if you want to refine that mesh, you can go for here and you can define the mesh settings here. So the default size that what I'm taking here is 8.1, and if you want to adjust the element size for your FEA, you can control here. And finally, if you want to go to this results, you can select the type of results you want, whether you want contour or whether you want this section. So what type of results you want from this organ again, so whether you want displacement or you want volume stresses, you can select that. In this case, I'm just going for this one. Results, I'm just selecting volume stresses, and it will click it OK, and it will calculate the results and it will give you the nice features. Okay, let me take the base point, let's say from here, and sorry, let me just quickly just go, let me go for that one. Okay, just have some errors here. Let me go to the same thing, and let me go to this content, and let me go to this FEA interior point, and let me give the supports here. So generate my support, and let me give some loads here. Let me give, let's say, 2000. Yes, and that's my mesh view. Yes, here 10, and finally let me get the results. And that's my base point. So this is what we missed last time. Okay. So once you just get your counterpart, and you can see the values, okay, based on the counterpart. And if you want the different results, let's say somewhere you want this displacement, you can also get that. You can click OK. And again, if you want to move that one based on the displacement, let me click here and let me play the results here. Okay, and so that's it. And let me close here. And if you want to see these results, let me scale this one. You can see it gives you different maximum as well as the minimum value. And by saying this contour, we can see this is my minimum value, and the value which is which is in red area, that's my maximum stress areas here. Okay, and you just go for this displacement here. Let me scale this thing. You can see again I have maximum displacement of up to 0.481816. By seeing this contour, this contour plot, we can make some assumption. Okay, so where we can see in the red area, right, that is where my maximum deflection is. Okay, so in that way also we could able to calculate our FEA calculations, and there is much more thing we can do with the FEA, but I just went with the simple uh, cantilever beam here. And these are the features that is available inside your AutoCAD Mechanical. And there is one more thing is available, is like structural tab, where we could able to organize our drawing. Okay, so with this limited time constraint, I'm just closing this session. And you can see the difference mainly between the AutoCAD as well as AutoCAD Mechanical, and how it's different from that of your AutoCAD. I know if you are an AutoCAD user, maybe you would have understood by this time how it's quite powerful it is, and where all the tools which is unique to the AutoCAD Mechanical, where we could able to easily generate your layers, and you can manage your standards and your construction lines and your BOM and everything, where we could able to generate within a very few clicks than compared to our main AutoCAD. Okay, uh, so that is for today's session, and we will try to meet in upcoming session. And if you have any doubts, you can put your doubts in the comment section, or if you can also mail me, and I will try to answer those queries. Okay, and So thanks for attending today's session, and we will meet in the upcoming sessions. Okay, thank you.